This is Lesson 1-1B from the Algebra Readiness textbook. To begin, you will need your notes and a sharpened pencil. Press pause to gather your supplies and work the first review problem. Once you've completed the problem, press Continue. Identify the expression as numerical or algebraic, then explain your choice. E minus 9. Because I see there is a variable, the letter E, in this expression, I learned in our previous lesson that indicates an algebraic expression. So on your answer sheet, you should have written algebraic, and then you need to explain your choice. I'm just going to use BC to represent because it contains the variable, and then make sure you name the variable E. If you got that right, then you have mastered what you were supposed to learn in the previous lesson. This first question that I call study guide is an exact replica of the question that will be on your quizzes and on your tests. So make sure you're always able to easily do the study guide questions because they will help prepare you for that assessment. The lesson target for today is that you can write your own numerical and algebraic expressions given the word problem. If at the end of this lesson you are unable to do that, make sure that you give me a call or email me so that I can help you. The next part in your notes indicates the writing in math. Let's start by going over some of the most common words and what operations that they indicate. Please fill in your table in your notes with me as we go. You can translate many words for operations into operation symbols. For example, when you hear the word total, like what is the total number of baseball cards that you have, that indicates addition, so write a plus sign in there. More than also indicates addition. He has five cards more than his sister. That would be adding. Increased by is also indicating addition. The word difference indicates the answer to a subtraction problem. Fewer than indicates subtraction. Less than indicates subtraction. Decreased by indicates subtraction. Product indicates multiplication. We are going to use these three symbols for multiplication. Times is also multiplication. Quotient is division. Division will be indicated with a division sign or with a fraction bar. Divided by is another division problem. And lastly, the word sum. You're going to have to add that one at the bottom. Sum is the answer to an addition problem. I would also like you to go by and put a star by these few. More than, fewer than, and less than. And the reason is because normally when you're translating word problems into numbers and symbols, you would just put them in the same order they occur, the same order that you read them in the word problem. The only time that you don't is if they have the dreaded than, more than, fewer than, less than. So be aware of that. If you hear the word more than, fewer than, or less than, the numbers will switch order. Let's give a few of these a try. So we're going to practice translating word phrases into variable expressions. So on the left is our word phrase, and on the right is the corresponding variable expression. So 9 more than a number. I'm seeing the word more than. I look over to the writing in math and I see more than has a little star by it. So that tells me that the order might be a little wonky. I can't write 9 plus y. I'm saying that there is 9 more than the number y. that means that y is already there. I have y amount, and I'm going to add 9 to it, y plus 9. Please write that on your paper now. The next problem, 4 less than a number n. Well, less than indicates the operation subtraction. It also has a little star by it, so I know that I need to use, or that the order of the numbers is going to reverse. This is not going to be 4 minus n. That would be incorrect. It is 4 less than the number n, meaning I already have n of something, and I am going to have 4 less than that, n minus 4. A number z times 3 can be written as z times 3, or the better way to write it is 3z without any operation at all. We are going to understand that if we have a number next to a variable, it always indicates multiplication. It always indicates multiplication. And actually, the best way to write it is the 3z. So try to get used to writing it like that. A number a divided by 12. A, fraction bar, 12. Now, if you wrote a divide sign 12, that would be equally correct. The next one, 5 times the quantity 4 plus a number c. Well, 5 times the quantity 4 plus a number c, the word a quantity means that I have to put parentheses after this set of data, 4 plus a number c. So 5 times 4 plus c would look like that. You could also write it as 5 times 4 plus c without writing the multiplication sign, because a number separated or next to a set of parentheses means multiplication. So a variable expression is an efficient way to express a mathematical relationship. Okay, let's practice some of this now. I've thrown a lot at you. Let's practice. In your notes, I would like you to try these 6 on your own. Pause the video. When you have completed these 6, come back, hit play, and we will review and compare your answers to what I get. All right, let's give these a try. 9 less than k. I see the word less than, and so that sends off red flags in my head that I'm not going to write 9 minus k. I'm going to switch the order to k minus 9. Number 8, m divided by 6. You might have written m divided by 6 like this, or m divided by 6. Number 9, twice x. Twice means 2 times, so 2 times x. Or you might have written 2 times x like this. Number 10, 4 more than twice x. Well, now I've got 2 parts to do. Well, how can I write twice x? I would write twice x like I did in number 9, 2x. Then I need to do 4 more than that. Do you see how I broke that apart into steps? More than means I need to add the 4 at the end. I don't write 4 plus 2x. That would be incorrect because I had twice x and I'm increasing that amount by 4. Number 11, the sum, that means add, of 18 and b. So just the order it occurs, 18 plus b. Number 12, 3 times the quantity 2 plus a. Well, let's break this apart. How do I write 3 times, hold on, I see the word the quantity, which means do that first. put whatever's after it into parentheses. So 2 plus a in parentheses, and then do 3 times that. So I actually could just put 3 times 2 plus a like that. Or if you like to squeeze a little dot in there for multiplication or a little star sign, go ahead and do that. We're going to avoid using x to represent multiplication this year. All right, let's do a little bit more practice. So why do we need 2 types of expressions? We have numerical and we have algebraic. Let's look at this example about gas mileage to help us understand. So gas mileage is something that adults talk about in regards to their cars or their vehicles. And gas mileage simply tells us how far we can drive on 1 gallon of gas. So every car has a different gas mileage. Take a look. A subcompact car is just a weird fancy word for a type of car. In that particular car, the owner drove 330 miles on 10 gallons of gas. Well, that doesn't really help me to know what my gas mileage is. I can find out how many miles I could drive on 1 gallon of gas by dividing 330 divided by 10. That is a numerical expression. This is a numerical expression to help me find out how many miles I could drive on 1 gallon. Take a look. What if I had a compact car? That just means a small car. This owner drove 300 miles on 10 gallons of gas. To figure out their gas mileage, they could use the numerical expression of 300 divided by 10 gallons. Another numerical expression. Another individual owns a mid-sized sedan. They drove 240 miles on 10 gallons of gas. To find out or calculate their gas mileage, they would take 245 divided by 10, another numerical expression. Another person owns a sports utility vehicle or an SUV. To find their gas mileage, you would take 175 divided by the 10 gallons. Lastly, if you owned a pickup and you drove 160 miles on 10 gallons of gas, to find your gas mileage, you would use the numerical expression of 160 divided by 10. That's all helpful for all these different kinds of cars and for these specific situations. However, if I said that I owned a vehicle and I drove M miles with my vehicle, I could take M miles and divide it by the 10 gallons of gas to tell me my gas mileage for any vehicle. So an algebraic expression or a variable expression helps us to come up with a rule for any vehicle to use. So numerical is good for a specific vehicle. Algebraic expressions are good for finding a rule. Let's apply that to the next example. We're going to go out for bagels, and bagels cost 50 cents each. Step 1, let's write a numerical expression. We want to write an expression for the cost of 12 bagels. Well, if they're 50 cents each, I might write 12 times 50 cents. Make sure you write 50 cents as a decimal, because that's how it's given in the problem. Now, what if I wasn't sure or I wanted a rule for any number of bagels? I might use an algebraic or variable expression. Write an expression for the cost of B bagels. Well, I just take the number of bagels I want, B, and multiply it by 50 cents. I now have an algebraic expression for the cost of the bagels. Okay, now it's your turn. You're going to pause the video and give the next problem a try. Wait, hold on. I thought I was at a different spot. Okay, wait, let's try this one. Let's try this one together. The value in cents of 5 quarters. Well, I know that 1 quarter is 25 cents. So the value in cents of 5 quarters would be 5 times 0.25. What is the value in cents of any number of quarters? You would take quarters times 0.25. But we also learned that when you are using a variable, you like the number to be written first, 0.25Q. So the second way is the best way to write it, but either way is correct. Look at the next one, the number of months in 7 years. Well, I know that there are 12 months in 1 year. So if I wanted to know the number of months in 7 years, I would take 12 times 7. How about if I wanted to know the number of months in Y years? 7 times Y. Now, the number of gallons in 21 quarts. This is going to take some dusting off from what we learned of some memory from last year. In 6th grade, you learned that there were 4 quarts in a gallon, and that's pretty important to remember. So if I have 21 quarts, I could take 21 divided by 4, and I could write it as a fraction, or I could write it using the division sign. The number of gallons in Q quarts would be Q divided by 4, or Q divided by 4 like this. All right, I think we've got the hang of this. Now I'm ready to give you a try, let you try this out on your own. Try these two on your paper. Pause the video, then hit continue as soon as you are done, and you can compare your answers with what I got. All right, the number of hours in 5 days. Well, I know that there are 24 hours in 1 day, so 5 times 24. Now, you do not have to do the math and get me the actual answer. We're just writing the expression, not calculating the answer. The number of hours in D days. Well, if I know the number of days, I just multiply it by 24, and then I remember, variables are supposed to come after, so I would write 24D to mean 24 times D. All right. Space aliens. Tokens cost $1 for 4 tokens. How many tokens can Josh buy if he has $5? Well, 5 times 4. Again, do not write the answer, just the expression. What if he has $8? 8 times 4. What if he has $6? 6 times 4. These are all numerical expressions. What if he has D dollars? Well, instead of the 5 or the 8 or the 6, I have D times 4. But again, we like to write it properly, so we would write 4D. All right, now you can try. A shirt costs $15 and jeans cost $25. What is an expression for buying S shirts? What is an expression for buying J jeans? What is an expression for buying shirts and jeans? Hit pause on the video and come back after you've tried these 3. All right, let's give this a try. What is the expression for buying S shirts? Well, it's $15 for each shirt, so 15 times the number of shirts. 15 times S. What is the expression for buying J jeans? Well, 1 pair of jeans costs $25, so for each pair of jeans, I'm going to pay $25. 25J represents the cost for buying any number of jeans. What is the expression for buying S shirts and J jeans? Well, I'm going to add those together. 15S plus 25J gives me an expression to calculate my total bill. Now I need to substitute. What is the expression if I wanted to buy 3 jeans and 5 shirts? That means that my J equals 3 and my S equals 5. Let's rewrite the problem down here and substitute the numbers in. I would take 15 times 5, because I'm going to take this 5 and put it in there, plus 25 times 3. I just took this 3 and substituted it, swapped it out for the j, and now I can solve. 15 times 5 is 75. 25 times 3 is also 75. And so my total is $150 spent on shirts and jeans. Oh, sorry, I did more work than we needed to. You only had to write this expression right here. It says, what is the expression? And I went and solved it. Don't do all the extra work. All right, the last problem in our lesson today. Emily has twice as many sports cards as Jose. Then she buys 4 more for $2 each. Use the variable x to write an expression for the total number of sports cards Emily has. Pause the video and try to work these 4 problems. Press continue when you're ready. Okay, let's give this a try. What given information is not needed to write an expression for the total number of cards? I find it best to read every word problem at least twice. Emily has twice as many sports cards as Jose. Then she buys 4 more at $2 each. Use the variable x to write an expression for the total number of sports cards Emily has. I'm trying to discuss the total number of cards, not the price or the total cost of each card. So that tells me that the fact that they were $2 each is unnecessary information. So what information is unneeded? $2 each. I don't care about the cost. Next, what unknown information will the variable represent? Well, they already told me that my variable is x. X needs to represent Jose's number of cards, because that's the information I need in order to find out what Emily has. Emily has twice as many cards as Jose. If I know how many Jose has, I can figure out how many Emily has. So Jose's number of cards is my starting point. What operations should you use to represent the phrases twice as many cards? Well, when I see twice as many, I think multiply by 2. When I see buys 4 more, that indicates to me addition. So I'm going to have multiplying and adding. Now use the variable to write an expression for the total number of sports cards that Emily has. Well, twice as many cards would be 2x. Then buys 4 more would be add 4. 2x plus 4 is my variable expression to represent the given scenario. Congratulations if you got that. Great work. I think we're ready to put this into practice. Your homework for tonight is is right up here. Please take out a piece of loose leaf paper and write your first and last name at the top. Write the hour you have math, and then label 1-1B, because remember, this is where to find your answer key on Google Classroom. Page 6, numbers 11 through 20 and 25 through 31. Please make sure you contact me if you have any questions.